Welcome friends, so I'm going to give you a visual interpretation of the chain rule using two variables. So again, on this channel I post some advanced, more non-routine types of math videos. So imagine we have the following scenario. So this is x and this is y and then this here is z. Again, I will try to make it visual, so it's kind of obvious really. Now imagine for the chain rule states we have dz dt for like this. This is equal to partial z and then partial x and then dx dt, because x depends only on t, and then we add to this dz dy because z depends on x and y, so you have to use the partials there, and then you're going to multiply by dy and then dt. Now let's think about what this is saying. So let's analyze the terms, like this term right here. That says x is a function of t essentially. So how can we incorporate that into the picture? It's not obvious, but what we can do is just put on t-axis here. Why not? Okay, sorry. And then this is x right here. So let's think. If this is like where you're beginning on the t-axis, then when you end up here, right, then this is like a bit of a delta t right here. And then we draw some curve that represents, for example, how x changes with respect to t, the function. So then what we can do is this. Take a look. I have to be careful with the way I draw this. So it looks like this. Okay, and then I'm going to map over back to this axis like that. There you go. So this should be a bit more parallel to the x-axis. So now look, this is a little slope triangle. This is still delta t here, but now this is delta x. But that means this delta x right here, it's also delta x in this position right here. Now, again, the question then is, what about this part right here, dy dt? Well, so because this is the y-axis, you can just draw an independent t-axis back here. Why not? And then what we can do is the following. Just draw some curve that represents, for example, how y, behaves with respect to t. Here I'm just using straight lines, but these curves could be sines, cosines, whatever. Okay, t squared, whatever. Then here again, imagine you begin here and then you go this way. So that's delta t. But as that occurs, then of course, what happens on the curve that represents the behavior of y? Well, you have again a slope triangle. So this is delta t, that means this is delta t still, but this is delta y, which means this here is still delta y. So this increases here, y increases this way. So it goes this way. So just like here, x goes this way. Let me emphasize that, right? In terms of arrows like this and like this. Now, that accounts for this and this, because now I have delta y over delta t, which is like dy dt. I have delta x over delta t here, which is like dx dt. Look what happens. Imagine I have some surface floating up here. Okay, like that, some surface hanging above the xy plane. And let's kind of map this to here, then map this to here. And we have a situation that pretty much looks like this. You see, it's like a little triangle that gets formed. This is still delta x, and this is still delta y right here. So now, think about this. Beginning from here, delta t, when that goes this way, right, then goes this way, delta x goes this way. So that means you go from here to here. Beginning from here, when you go here, then delta y goes this way, which means you go this way right here, right? So this way followed by this way, roughly speaking. Now on the surface, go up to the surface right here, okay? Say this is this point right here. And then translate delta x also over to here. So this segment right there, that's just a copy of delta x from below. So call it delta x. Try to keep this parallel to this. And then copy the delta y, but let's be careful for a second. You see, what about this part right here? I'm going to incorporate that. Well, when delta x changes this way, then this will change this way, go up this way. So we can call this part right here, we'll call that delta z, like with respect to x. Okay, the change in z with respect to x. So again, think about it. This goes this way, delta x goes this way, and as that occurs, then z goes this way. It changes, say, by this amount. Okay, now look back here. When delta t goes this way, then delta y goes this way, and as that occurs, then let's say we stop here and then we go this way. So that means this is delta y still up here, that little segment. And then as that goes from here to here, then delta z has its own change due to that, which could be, say, like this part right here. So we'll call that delta zy. So that means the overall change, if you think about it and everything, first of all, I hope this, clarifies what's going on here, that multiplying, well, in other words, forming dy dt, which is just a slope here, that's the rate, and then you multiply by this, it kind of brings you here. And then the same thing with this one, correct? So the dt is like delta t, that's the slope here, and as that changes, you multiply by the second rate of change, and that brings you to here. In other words, we have the total change that emerges that's basically like this part right here. Okay, like this. That comes from doing something like delta zx plus delta zy, right? That would be our total delta z, which comes from both, really. So this is a way to visualize the chain rule and the concept of a differential, if you think about it. I'll leave it here, though, so please be sure to like and subscribe if you're into more advanced and abstract math videos.